Welcome back to Algebra 1 with Miss Betsy. Today we are going to simply be solving some quadratic equations. What we've done up to this point is we've focused on a particular method of solving quadratic equations. Sometimes we use the zero product property, we use the method of taking roots, we completed the square. We also use the quadratic formula. And now we're just going to go through some practice where we throw a question out there and we say, solve it whatever way works. Whatever way works for you. I'm using as my text the second edition of Algebra 1. It's published by Bob Jones University Press. I'm in section 11.7 on page 470. My lame joke for today, my daughter's sitting right here with me, let's see if she laughs. What do you get if you mix a rabbit and a snake? She has no clue. You get a jump rope. And she rolled her eyes, so that must have been very lame. Okay, general method of solving quadratic equations. If you would look at your text, those of you in my co-op classes, it says, put the equation in the standard form. We have ax squared plus bx plus c is equal to 0. Ax squared plus bx plus c is equal to 0. And then we want to look and see what we come up with. Well, if b is equal to 0, then we're going to use our square root method. What happens if we have b equal to 0? Well, you've got something a squared minus 17 is equal to 0. We're going to solve this equation by taking the roots. We're going to isolate the square term. We have a squared is equal to 17. So a is going to be plus or minus the square root of 17. So that would be the most common reason most common illustration or example of why you would solve an equation by taking roots. And then it says if the polynomial factors solve the equation by factoring. That qualifies as a duh. If we have a squared plus 7a plus 6 equal to 0, that's easily factorable. You have a plus 1 and you have a plus 6. And it's easy to see that the solution is a can be either a -1 or a negative 6. Otherwise, you're going to want to use the quadratic formula. And I want you to notice that it doesn't say solve by completing the square. You're perfectly welcome to solve an equation by completing the square, but really, the reason they had you, I believe, learn how to complete the square is so that you would be able to understand how they derived the quadratic formula, which I didn't even go into yet for this year's co-op class. So let's go ahead and look at some examples and see what we have. I'm on page 470, and I believe that I am going to do, I had picked out several and hadn't written them down, but we'll just pretend that I'm in class. Example 2 is, problem number 2 rather, is x squared minus 3x minus 5 is equal to 0. This is number 2 in the problem set for 11.7 on 470, page 470. We're going to look at this and solve it. It doesn't give us any requirements as to how we solve this. So we have this set up where the polynomial is equal to 0. We have a first degree variable here. B is not equal to 0. So we're not going to solve this by taking the square root of both sides of the equation. Also, this isn't factorable, is it? There are not two factors of 5 that when you add those two factors together you end up with a -3. So we don't want to complete the square. We're going to use the quadratic equation. What is the quadratic equation? That says x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c. All of that is divided by 2 times a. We look here, let's see what our values are for A, B, and C. A is equal to 1, B is a negative 3, and C is a negative 5. You remember that A is the coefficient of the squared of the leading coefficient. B is the coefficient of the first degree, or the center term here, which is a negative 3, and negative 5 is our constant term. Now we simply substitute in and solve. X is equal to the opposite of a negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times a negative 5. All of this divided by 2 times 1. Now you guys need to do this just because you need to be making sure that you've done your substitution correctly. I need to do it as well because I'm trying to teach and write and talk at the same time. Make sure that I've got my substitution correctly. B is a negative 3, so I have the opposite of negative 3, negative 3 squared. A is 1, C is a negative 5. So I've shown my substitution correctly. Make sure you use parentheses. That makes it less likely that you will drop a negative sign. What do you do now? Simply complete your algebra. You have X is equal to 3 plus or minus the square root of 9. Right here we have minus a negative, so it's plus 9 plus 20. All of this divided by 2. X is equal to 3 plus or minus the square root of 29 divided by 2. And that's all that there is to solving this problem. You could go ahead and check this by substituting back for x 3 plus the square root of 29 divided by 2, and then 3 minus the square root of 29 divided by 2. Would be some involved calculations, but you could verify this. As long as you're stepping through and doing your work correctly, this is what your answer is. 29 is a prime number, so there is no square. These are the types of answers that you're going to get to problems like this. Now let's go ahead and look at another one. Let's do x squared minus 21 is equal to 4x. X squared minus 21 is equal to 4x. What in the world are we going to do with this problem? This is problem number 6. Well, the first thing that you want to do is set the polynomial equal to 0. X squared minus 4x minus 21 is equal to 0. And then we'll go ahead and use the quadratic equation to solve this. Correct? Well, you can always use the quadratic equation to solve. But first, take a moment and see if you can factor it. Are there two factors of a negative 21 that when you add them will give you a negative 4? Sure. This is factorable. We have x minus 7 times quantity x plus 3 is equal to 0. Negative 7 times a positive 3 is negative 21. Negative 7 plus 3 is a negative 4. So we were able to quickly factor this problem, and we have that x is equal to a negative 3 or 7. Would you have arrived at that same answer if you had chosen to solve this problem using the quadratic formula? Yes, of course you would. Probably would have taken you longer. Now, let's look at number 19. Actually, I want to do number 24 instead. Let's think about 24. This is the quantity 3x minus 1 squared plus 6 is equal to 0. Okay, we have this already set up in ax squared plus bx plus c is equal to 0. We don't have that center term, so b is equal to 0. Now what did they tell us to do at the beginning of this section? It said if b is 0, let's go ahead and solve this. Use it by taking the roots of both sides of the equation. We have the quantity 3x minus 1 squared is equal to a negative 6. So we can just go ahead and take the square root of both sides of the equations, right? Square root of this, square root of this. No, there are no real solutions to this problem. No real solutions. How do I know that there are no real solutions to this? Well, can you take the square root of a negative number? Can you tell me what the square root of negative 6 is? I can tell you, but that's because I know something you don't know. This is not a real number. In the real number system, at the point that you're at right now, you cannot take the square root of a negative number. So there are no real solutions to this. So you have to always be careful to be looking at your problems. It would be very easy to say, oh, I've got this set up. Take the square root of both sides. 3x minus 1 is equal to plus or minus the square root of negative 6. And then continue down the wrong path. No square roots of negative numbers. Okay? You have lots of things to be looking for in these types of problems. Let's look at another one and see what we have. Let's go ahead and go back to negative t squared plus 4 is equal to 0. One thing I don't know that I've emphasized yet, our leading coefficient, or the coefficient of the highest degreed term, when we're solving these equations, we always want that to be positive. But for now, I'm just going to go ahead and write some extra steps. I have negative t squared is equal to a negative 4. Where the opposite of t squared is equal to negative 4, we divide both sides of this equation by a negative 1, and we have t squared is equal to a positive 4. Alternatively, for your next step, you could have said 4 is equal to t squared. Really makes no difference. Or you could just have looked at this and known to jump immediately to t squared is equal to 4. We're at that point in your progression through Algebra 1 that it is normal and perfectly acceptable to skip some steps. Just be careful with your negative signs when you do that. Now we do have t squared is equal to 4, so we're going to take the square root of t squared is equal to plus or minus the square root of 4. So t is equal to plus or minus 2. This is one where you can take the root of both sides of the equation because you're taking the square root of a positive number. Let's see if there's one more problem to do. How about this one? This is problem number 28. We have quantity x minus 6 times quantity x plus 2 minus quantity x minus 6 is equal to 9. What in the world are we going to do here? And what trap have they laid for you? We have x minus 6 minus x minus 6. If you're not careful here, you're going to think that's a plus this and a minus this, and they cancel out. No, These are not like terms here. This is a term, quantity x minus 6. This here, however, is not a term. This is a factor. And this is a term. You can only add and subtract like terms. You cancel common factors. What we have to do here is use our FOIL method to multiply these two binomials. X squared plus 2x minus 6x is a minus 4x. Negative 6 times 2 is a negative 12. X squared minus 4x minus 12. We're going to distribute a negative sign here. Minus x plus 6 is equal to 9. Now we need to go ahead and combine like terms. We have x squared minus 5x minus 6 is equal to 9. Now, we can go ahead and factor this, can't we? Yes, but you cannot factor until the equation is set equal to 0. So to factor polynomial must equal 0. I'm going to subtract 9 from both sides of this equation. X squared minus 5x minus 15 is equal to 0. Alright? Now, all of a sudden you can't factor that anymore. You have factors of 1 and 15, 3 and 5, and you cannot combine those to get a negative 5. What do we need to do now? Yeah, we need to solve this using the quadratic equation. So A is 1, B is a negative 5, and C is a negative 15. I'm going to go ahead and erase everything that I've written here so that we can solve this using the quadratic formula. Quadratic formula says x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all of that divided by 2 times a. We're going to substitute in the values that we have. Opposite of a negative 5 plus or minus the square root of negative 5 squared minus 4 times a is 1, c is 15. C is a negative 15. That would have been a problem had I dropped that negative sign. All of this divided by 2. Now let's see what we have. Make sure I've done my substitution correctly. B is a negative 5. Negative 5 squared. 4 times a is 1. C is a negative 15. Divided by 2 times 1. I now have x is equal to 5 plus or minus the square root of 25 plus 4 times 15 is 60. All of this divided by 2. Now we're going to have the square root of 85. X is equal to 5 plus or minus the square root of 85. All of this divided by 2. Are there any perfect squares hidden in 85? I don't think so, but let's check and make sure. 85 divided by 5. 5 times I am brain dead. 5 goes into 8 one time. 5, 35. is 5 times 17. Both of these are prime numbers. No perfect powers in there. So our solution to this problem is x is equal to 5 plus or minus the square root of 85. All of that divided by 2. There's nothing in common that we can factor out. So make sure that you work through a lot of these examples. Use whatever method works best. You may not use the same method that your classmate does. Doesn't matter as long as you arrive at the same solution. And that's the end of our video for section 11.7. If you get stuck, send me a text. I'll talk to you later.